Okay, I'm going to put up how to construct a square inscribed in a circle for those of you who were not there or those who were there and just want to watch it to get the idea once again, practice maybe, or just look at to get it solidified in your mind. So the first thing we need to know is, what is a square? Well, here's the definition of a square. A four-side figure with the following properties. All side lengths are equal and all four interior angles are right angles. So the ones on the inside are all right angles. And if you have a shape and you are told that all sides are equal, that doesn't tell you enough, because you can have, if you did the extra credit video, you realize that a rhombus actually has side lengths that are equal, but the interior angles are not right angles. So you have to be more specific. When you have both of these properties, you have a square. Alright, so the first thing we're going to do is draw a circle. I'm going to draw my circle. Now you always want to mark the center point, because that's going to be very important for our construction, to know where the center point is. Alright, that's a pretty big center point. I don't need it that big, but just for the sake of our thing, I'll just leave it like that. Okay, we want to know how to cut this in half. That's going to be the first step we're going to take, is how to cut this in half. So if I draw the diameter, and hopefully you remember what the diameter is, but this is not the diameter of a circle. This is not the diameter. And this is not the diameter. Alright, all of these are lines that touch both the circle twice. Line segments that touch the circle twice. However, the only one that is going to be a diameter is the one that goes right through the middle. So this, that goes through that center point rather. So this would be a diameter, this line. If I drew one here, this is also the diameter. I'm going to leave this one because that is going to be easier for me to work with. You can use any line that goes through the center. That is going to be the diameter, and you can start with that. It's going to be easier for me to construct with my line looking like this. Alright, now we need to cut this in half. Now think about how, not in half, we already cut it in half. We want to cut into 4 equal parts. We have 2 equal parts on top and on the bottom. Those are equal. They have to be, if this is our diameter going through the center point, which it is, these have to be equal parts. So what if I, when we talked about the class with this, what if I did this? If I did this, this is obviously not 4 equal parts, right? And what if I said, okay, well, no, I won't do that. I'll do, let me see, I'll do a line that's like this. Well, it looks like that's closer than the last one, but still not there. Well, what if I, okay, so I'll take that one away and maybe I'll go like this. Well, now, again, that looks like it's a good job, but when you're doing constructions, you can't just draw something and hope that you are doing a good job. You wouldn't want people building buildings who are just eyeing something. You'd like them to have, be sure that what they are doing is going to be a straight line. And as you could notice, hopefully you notice that the closer it gets to 90 degrees, this line with our diameter, the closer it gets to cutting in half. So if you go back, look at the lines that I drew, the examples. This one was really not close at all to cutting into 4 equal parts, right? 1, 2, 3, 4, obviously not equal. Then I drew this one, and that was a little bit closer, but still not there. If I take out my protractor, we can see that if I take this and I'm going to take this here, we can see that right here, that's, what is that? That is 46 degrees, and this right here would be 77 degrees. I want to have 90 degrees, but we're not going to have a protractor. So how would I do this if I did not have a protractor? So I'm going to get rid of this and get rid of these angles. And if you think about the constructions we have done, think about the ones that included something that had to do with 90 degrees. Only one that I could think of that we had that had to do with 90 degrees. and that would be the perpendicular bisector. So what we can actually do is draw a perpendicular bisector on our diameter. So we can actually construct the perpendicular bisector, right? We already know where it is cut in half, so really, that part is not something we need, but we do need the points at the top. We do need to have that in order to cut it in half. If we do it perfectly, our line should go through, once we do our this part, this should go right through the center point. If it doesn't, then something went wrong. Alright, let me now, let me get out the, I'm going to put up the actual instructions that we had, that I put up right here. So I'll copy these and go here. Alright, so these are the steps. You can stop the video and write these down. I'm not going to dwell on these, but this is it here. So I'm going to move these now. I'm going to move these arcs that I made. Now we think to ourselves, we have everything we need in order to construct our square. So the next thing we're going to do, and think about it, maybe you want to pause it and think to yourself, what would I want to do? Alright? Okay, maybe you figured it out, maybe you did not, but let's go ahead and finish it up. We have 4 points here. 4 points. And what we're going to do is connect these together. We have here. Now I had some students say in class, well, we constructed a diamond. Well, I know you've heard the term baseball diamond before, but really a baseball diamond is a square, because if you look at it, from home plate to first base is 90 feet, first base to second base is 90 feet, and second to third 90 feet, third to home is 90 feet. So it's actually a square. They call it a diamond, but it's actually a square. So that's our square here. And we could go in, we talked a little bit about how we know it was a square, how we know all of these sides are the same, but this is how you do the construction. So, pause it. Okay, here's your first bonus question. I labeled triangle ABC here. That's part of the square. And I want you to tell me, is ABC an equilateral triangle? Why or why not? You have to explain, and it's not good enough to say it looks like it is or it looks like it's not. You have to think about the construction that went into making this square, and from that you would have your evidence of whether this is an equilateral triangle or not. So that is your first bonus question I'd like you to answer. Okay, here's the next bonus question. Looking at this new figure, I've created now, actually I have a square inscribed in a circle, and I actually also have a circle inscribed in a square. But I want to know, based on this, how many squares do you see? And this will maybe help you with the next part of the bonus. So tell me how many squares you see here. Okay, the next part of my question is actually the last bonus question I think for this. Is I want you to tell me what is the area of ABCD in relation to square EFGH. So what is the area of square ABCD square ABCD, that'd be A, B, C, D, in relation to square E, F, G, H, which would be E, F, G, H, this big one. So what is the area of this square in relation to this square? Now, you're not going to be able to tell me any actual areas, but you can tell me and prove to me. Now, saying something and just saying it looks that way is not good enough. You have to be able to explain to me how you know, and you have to be able to write it down if you want credit for this. Now, I'd be impressed if you could come and just tell me, but I'd like you to be able to write it down for extra credit. So that's your question. What is the area of A, B, C, D in relation to E, F, G, and H? All right, there's a lot of ways to go about this. The fact that I put an I here, or I labeled this point, the way I did this, that would have been important. It might help you out. Maybe, maybe not. I don't know. All right, so go ahead and try it.